about that.
Is that true?
I'll talk loudly. It's easy. Just a couple of things. I mean, I summarized the stratigraphy in the guidebook. What I want to mention is the Wildcat group, which I brought Ogle's map, is actually a very good job of mapping from the 1940s, and the Wildcat group is in these brown color tones. Basically, it's deformed into a large synclinal structure which has a lot of internal faulting.
Oh, thanks, Harvey.
Dipping northwards on the south side of the Eel River Basin and southwards on the north side. And the unconformity with the Yager complex, which is a Franciscan terrain, is well exposed near Scotia. At Centerville Beach, there's a shear zone which truncates the bottom of the Wildcat group. And I have some maps which you can't see here that you can look at later or at lunch, which deal with the structure. And basically, we have a lot of offshore faults related to the fold and thrust belt, and they're being rotated and essentially turned to a near vertical orientation at Centerville Beach. The Russ Shear Zone is one of them.
Tim, where are we on that map?
We are, where are we?
We're
off the map. But actually, if you take this off, so we see the Wildcat group exposed with the stipple pattern here, and these active thrusts and so forth are being rotated and turned up on end in the vicinity of the triple junction. Now, just recently, this past winter, a landslide dammed the Eel River to some degree at Scotia, and a new exposure of the base of the Wildcat came to light. And I yesterday made the stratigraphic section. Last Thursday, William Miller, our paleontologist, and I went out there and looked at the exposure. And it has a lot of trace fossils. I have a photograph of the basal conglomerate and photograph of some of the trace fossils, and William's not here. I'm not a trace fossil specialist, but the trace fossils demonstrate beyond the shadow of a doubt that at Scotia we started out with a wave-cut platform developed on the Yager complex, which is about 40 million years old, isoclinally folded. And we had some debris flow deposits come in, and then some sands with a lot of bioturbation. And the trace fossil assemblages demonstrate that we're in a nearshore marine setting. And then going up section, 100 meters up section, you're in a couple of kilometers of water depth. So the bottom dropped out, in essence. We started out with a shallow marine setting, and the leading edge of North America underwent a tremendous tectonic subsidence, and this is about 6 million years ago. And the same story exists up at Crescent City. On Sunday, we'll see the St. George Formation, which is coeval with the basal Wildcat group. And again, about 6 million years ago, what basically happened with the St. George is we had a coastal forest suddenly submerged, probably in conjunction with a tsunami event. And the shoreline at 6 million years ago can be found way up on the Klamath erosion surface at a few thousand feet elevation, about 20 miles inland from Crescent City. So basically the long and the short of it is, which I summarize in the brief thing in the guidebook, is we view the Wildcat group and the St. George all as part of a shelf sediment blanket that covered the western coast ranges in the late Miocene. And you started out nearshore marine, then there was a tremendous tectonic subsidence, and so the shoreline migrated inboard into the Klamath Mountains. And then basically the rest of the history of Wildcat sedimentation is aggradation of sediment in this sort of shelf slope setting. And we go through a bunch of formations, and by the time you get up to the Scotia Bluff sandstone, you're in a barrier island type complex, and then the Carlotta Formation is fluvial, and there are marine, non-marine cycles in it, which probably reflect Pleistocene glacial eustatic fluctuations. And then the whole assemblage was tilted, deformed into this large syncline with a lot of internal faults, which you'll be hearing all about, and stripped away by erosion. So you find little bits and pieces of wildcat down near Garberville and here and there in the Coast Ranges, but largely the bulk of it is preserved in the Eel River Valley, flanking the valley. The other interesting thing is argon dates on micas, which Kathy Moley picked out of the wildcat group years ago, and most recently Sam Lanningham of Oregon State picked out of the St. George Formation, demonstrate that the marine portion of the wildcat group has an Idaho signature. So we feel the Klamath Mountains in general were a lowland surface 6 million years ago, and some sort of fluvial system was bringing detritus from the Idaho batholith to this area here in the Eel River Basin and up at Crescent City. And this Idaho signature is found all the way through the marine portion of the wildcat group, and the cutoff where we lost the Idaho signature is in the Carlotta Formation, which is Pleistocene. So we view the uplift of the Klamath Mountains and Coast Ranges in northwestern California as a Pleistocene event. And why did this happen? Well, probably due to two things. One, the impingement of the Sierra Nevada block northwestward, which Mark has written a lot about, and also the fact that we're underplating a lot of sediment under the Klamaths. The accretionary wedge out here is nowhere near as large as it should be, given the duration of influx of sediment from the east. There are gas seeps through the Josephine ophiolite at Gasky on 199. So there's a lot of sediment subduction going on, and that's probably contributes to the uplift of the Klamaths. My 15 minutes is up, but I'm happy to talk for hours about this.
That'll have to be later, Ken.
Okay. Is everybody happy so far?
Yeah.
Okay, we're going to bring a seismologist.